In this video, we're going to go through 5 questions that are related to how the alpha and beta particles and also the gamma waves, how do they behave in the region of electric field or magnetic field. Before we start, maybe we do a quick recap. Alpha, beta, and gamma. Alright, this is alpha, beta, and gamma rays. So alpha is actually a helium nucleus, which is 4-2, and so the net charge or a relative charge is a positive 2 because of the 2 protons here. And beta is actually an electrons, okay, so it's 0, -1, and since electrons is negative charge, so the relative charge here is -1. And gamma, there's no charge. So having said that, you should know that gamma will just pass through the electric or magnetic field without any bending, with no deflection. But on the other hand, because alpha and beta are charged, they will be affected by the electric field and magnetic field. But one thing to note is, since both are opposite charge, the direction of the deflection will be opposite for both. Another thing about the size or the how massive the particles are is quite important. As you know, helium is bigger in size and mass compared to the electrons. So that's one thing to take note of, because how they are deflected by how much, that will be affected by their mass. Let's start with the first question. You have an emission from a radioactive source that's over here on the left, and it will pass through the 2 charge plates. So this is positive plate and this is the negative plate. So it's going, the emission will pass through an electric field, and so they ask you what types of radiation reach the detector. The detector is just placed on the right hand side here. So as mentioned just now, if the emission were to go straight without any bending, without deflection by the electric field and go straight to a detector, that means to say that emission has no charge. So if it's no charge, it has to be gamma rays. So the answer will be D. But let's revise. How about this particle here? The path is as such. So will it be alpha or beta particle? Since it's deflected, it must be charged. And since the top plate is positive, and you know the laws of electrostatic, light charges will repel and unlike charges will attract. Since it's going out attracted to the positive plate, so this has to be negative, and that means this has to be beta. And on the other hand here, this one must be alpha particles. Why? Because it's attracted to the negative. Of course, it's repelled by the positive at the top. So this will be alpha. Another thing to take note, just now I mentioned already, can you see the angle of deflection? This is more gradual because helium is more massive. So due to its inertia, it will be deflected much lesser compared to the alpha particle. So that's one thing to take note of. Alright. Next question. Okay, which pair of properties is correct for beta particles? So just remember, beta is actually electrons, is -1 negative charge. So first of all, will it be deflected by an electric field? The answer is yes. As long as it's charged, it will be deflected. Okay, so another thing that you learn when you learn the basic of the emissions, you should know that beta will be stopped by or will be blocked by just a few of aluminium. So this is 2 cm, definitely it cannot pass through. Alright, so the answer will be B. Okay, next question here. So there are 3 emissions here, alpha, beta, and gamma, from a source S within the lab block, and there's a strong magnetic field present. But if you look at the question, you will not know what direction is the magnetic field. It's not stated there, but it doesn't matter. So as mentioned already, why the path of this emission just goes straight without any deflection. That means to say this has to be your gamma rays, because it has no charge, so will not be deflected by magnetic field. So we are left with X and Z here. So remember, I told you both are deflected in opposite direction. So one of them is alpha, one of them is beta, but which is which? So we take a look at its path. So can you see X is deflected a little bit only to the left compared to your Z here, which is deflected by a big amount, big angle like that. So that means to say this must be your helium, which is your alpha particles, because it's more massive. It's like, you can think of inertia. It's like, if I give you an example, this is a bowling ball and a ping pong ball, and both you roll it in this direction and there's wind blowing. Because the bowling ball is more massive, with a higher inertia, okay, it will be deflected a little bit. But if it's a ping pong ball with the same wind blowing to the left, it will be deflected by a bigger amount due to its smaller mass. So this will be your beta, because beta has much smaller mass compared to helium. Alright, so that's how you know Z will be your beta, and Y, as mentioned, is your gamma, and X will be your alpha. So the answer is B. Okay, so this question actually rather straightforward, because alpha particle is actually a helium nucleus, and so this will be a positive charge, and positive charge will definitely be deflected by electric field and magnetic field. So the answer will be A straight away. So, but let's revise. So alpha is positive, repelled by the positive at top and attracted by the negative plate below. So it will be bent, and then after that it will go straight. So alpha particle through a magnetic field, on the other hand, you should be applying your Fleming left hand rule, and this is the direction of the conventional current, and magnetic field is downwards. So it will be deflected into the paper. All right, the question never asked, but you should know all this. All right. So for the last question, you have an emission. There are two types of emission. So it's shown by the two separate paths here, and they ask you what are the emission P and Q. This one very straightforward, because P just goes straight without any deflection by the magnetic field. That means to say it has no charge, therefore it can only be gamma rays. And Q can also be alpha or beta, but so you're going to apply your Fleming left hand rule. That means to say, as the particle comes in here, there is a force acting downwards. All right, so that's why it will curve this way, and then you go straight after it exits out from the magnetic field. So pay attention to here. So the force is down. Using your Fleming left hand rule, your thumb pointing down, your first finger into the paper, you know that the conventional current will be to the left, but this charge particle or the emission is to the right. That means to say it must be like your electron flow. It must be negative charge, so it has to be your beta particles. All right, so Q is beta and P is your gamma, therefore D is the answer. So I hope with these 5 questions, you are able to understand the concept and able to apply them to all different kind of questions. All right, thank you.